So we're going to do number 25 in chapter 4 here. A problem in which it asks you to, well, estimate the magnitude and direction of a combination of vectors or of a resultant. But we're going to go one step further and actually find it mathematically. So in problem 25 here, the vector A has a magnitude of 27 meters and points in a direction 32 degrees above the positive x-axis. So positive x-axis, that's kind of a little bit different way to refer to a direction. So that's kind of like saying northeast for what we're used to, okay? So say make an imaginary little compass here for us to start our problem with, okay? North, east, south, west, okay? No big problem, okay? So when it says the positive x-axis, you think, okay, this part. And when you say 32 degrees above it, we're thinking exactly that, 32 degrees above it. So from here, the 32 degrees, we'll say is about right there. All we have to do for right now is estimate. And it has a length, or a magnitude, of 27 meters. So we'll make that about 27 meters long. We'll call that vector A. And 32 degrees. And magnitude 27 meters. Let me make this a little bit small. And then our second vector has a magnitude of 35 and points in a direction 55 degrees below the positive x-axis. So let's use a different color for this one. Let's say red. And remember that when we're combining two vectors, we have to draw them connected head to tail. So we're going to start drawing this next one right here. So if you need to, draw another imaginary little compass right here. And it says 55 degrees below the positive x-axis. So again, here's the positive x-axis. We're going to go 55 degrees below that, or south of it. So it's kind of like south of east. So 55 degrees below that. A little bit bigger angle. Just a smidge bigger. And it's a little bit longer of a vector. So this angle here is 55. This is vector B. And it has a magnitude of 35 meters. 35. There we go. So we know that we have vector A, and when we combine or add vector A to vector B, it should create some resultant, which we usually refer to as vector C, or sometimes referred to as, say, R. But in this problem, they refer to it as C. So let's first draw this resultant in there. We use pink this time. Now let's use green. So the resultant is drawn from the head of the first to the tail of the last. So there is our vector C. Let's try a little bit darker color. Purple maybe? So try this one more time. So there's vector C, and that. So that's our result. That's what we want to find the magnitude and the direction of. Is vector C there. So what we first need to do is find the components of A and B. Add the x's to the x's, the y's to the y's. And when we do that, we'll have the two components of our resultant. So just for fun here, let's go ahead and draw these components in. So the two components of A, this would be AY, it looks something like this, and AX, I didn't draw it very good, but you get the idea. So AY, AX, then for B, its components, we'll call those BX, a little bit better line here. BX and BY. Okay, so we combine AY with BY, and those two are going to equal CY. So since this is true, vector A plus vector B is going to be equal to vector C. We can say that AX plus BX is going to be equal to CX. And similarly, AY plus BY is equal to cy. And these two guys, those are the components of our resultant. When we have those, we can just use these to do a Pythagorean theorem to find the value of c. So if I want to draw these in here, I would say cy is going to look like this, and cx is going to look like this. Those are the sum of those other two. Those are the sum of those components. cy and cx. So, find components, add them. So, when we do that, let's make a little bit of a chart here. So, and we always want to make a chart, so let's, oh, too big. So let's try this one more time. Make our chart here. I don't know why it keeps getting so big, but we'll work for now. So, vector A and vector B, and the sum is vector C. We want to take our x components and our y components. So for vector A, how do we find the x components? We do 27 cosine of 32. Now those comes from the equation, just for any component for a vector r, any x component, rx, is equal to that vector times cosine of theta, the angle it makes with the horizontal, and ry, the y component, the vertical component of a vector r, is equal to that vector r times sine of theta of the angle it makes between itself and the x-axis. So those are equations we'll always be given on an equation sheet. Okay, and then we have 27 sine of 32, using those same equations for our y components. Now when we plug those into a calculator, both of those are going to wind up being negative. We can see that from the picture because it's above the positive x-axis. Y is positive because it says above the positive x-axis, and we can see where the picture is going in positive x because it's the positive x-axis, not the negative x-axis. So 27 cosine 32 and 27 sine of 32. Then for B, the equations are going to be 35 cosine of 55 and 25 sine of 55. Now, as you can see from the picture, one of these is going to be negative. The y component is going downward. It was 55 degrees below the positive x-axis, so that's like southeast. So we're going to, just to remind ourselves, before we even plug it into a calculator, we're going to make that negative. So I took a minute and found the values that go in here. I did make one mistake. I wrote 25 there instead of 35. We fixed that, so 35 sine of 55. And so AX is this, AY is this, BX is this, BY is this. So we add these columns together and add these columns together. So 22.9 plus 20.1, that gives us 43 meters. 14.3 plus a negative 28.7 is equal to negative 14.4 meters. Now it's important to double check these. Does that make sense? That the components for C, that the x component is positive, certainly, and that the y component is negative? Yeah, looks like the y component is going downward. Okay, so all of that's dwindled down to these two guys. These are the two components of our resultant. So we have to use Pythagorean, since these are the two legs of our right triangle. So let's erase all this other stuff that we don't need right now. We already found all that stuff. Already found it all. So there's vector C. Okay, and we have Cx, which we just solved, we said was equal to 43, and Cy, which is equal to negative 14.4. So we want to find the magnitude of it, and the angle we're going to find is actually this angle. Even though I drew the triangle like this, and this angle is outside the triangle, remember, as long as we're using these and our inverse tangent equation of y over x, it's always going to give us the right angle. And this is the angle we want. We want the angle that the vector makes with the x-axis, with the horizontal. So even if we drew it the other way, where we drew it like that way and then that way, it still winds up being the same thing. So let's first, real quick, do the Pythagorean theorem to find what the magnitude is. So C, the magnitude of C, is going to be equal to the 43 squared plus negative 14.4 squared. The negative winds up not mattering because it's, of course, getting squared. So quickly solve that. Squared. That gives us a final magnitude of 45.3. And always double check to make sure it's a realistic value and that it should be the longest side, and it is the longest side, and it definitely seems realistic. So that's our magnitude. And the other half of the answer is the direction. Now the direction, you have to find that angle. So the rule you always find, if we're using the right angle, the proper angle, inverse tangent of the y value, the y component is 14.4. You don't need to make it negative there because it doesn't matter. It'll just wind up confusing you because the negatives just indicate a direction, and since we're using an angle to indicate direction, we don't really need to use that in there. Should never have a negative angle. And we get an answer of 18.5 degrees. Now 18.5 degrees what? Now we can say south of east. We know that because y is negative, so south, x is positive, so east. But using the terminology that we use in this particular problem, let's wind up just using the same terminology. So let's say 18.5 degrees below the positive x-axis. And there's our direction. Again, either this or this. I prefer this, but your book always likes using below the positive x-axis, above the negative x-axis, that kind of thing. I will do more examples where they do that there. So there's a good two-dimensional solving for a vector problem. Again, it initially looked something like this, and we found the resultant. We made a chart, find the components for vector A, the components for vector B, add the x's to the other x's, add the y's to the other y's, and now we have the components of our resultant. Now the components of our resultant, which once we have those, all we got to do is Pythagorean theorem for magnitude, inverse tangent for direction, and we are all done.